Hello everyone and welcome back to the channel. We have talked extensively about how caching is a super powerful for boosting application performance, serving data at lightning speed. But there is a flip side to this power. The inherent challenge of ensuring that cached data remains accurate and up to date. This isn't just a minor detail, a fundamental problem in distributed systems and a critical concept called cache coherence or cache consistency. Today, we are diving deep into why this is such a hard problem and the fundamental approaches to tackling it. Okay, so what is cache coherence? At its core, cache coherence refers to the challenge of maintaining data consistency between a cache and its authoritative source of truth, usually your primary database, or even across multiple caches that hold copies of the same data. Imagine you have a user profile cached on two different application servers and that user updates their email. If one cache has the old email and the other one has the new email, or if both have the old email while the database has a new email, you have a coherence problem. Your application will start serving inconsistent or stale data, leading to a broken user experience. This problem particularly thorny because first, multiple copies, because data exists in the primary database, multiple cache layers, like CDN, a distributed cache, or maybe an application's local cache, and even a client-side caches. Number two, concurrent updates. In a modern distributed application, multiple users or servers might be trying to update the same piece of data concurrently. Number three, performance versus consistency. Achieving perfect real time consistency while maintaining a high performance is incredibly difficult, often forcing you to make trade offs. Okay. So, the fundamental problem, right propagation and steroids. So let's break down why this is such a big deal. The core problem of cache coherence manifests in two main scenarios related to writes. One, write propagation. How do changes made to the source of truth, which is your database, get propagated to all the relevant caches? If a user updates their password in the database, how do you ensure any cached copies of their old profile are updated or removed? Number two, stay reads. If a cache holds an old version of data and an application or user tries to read it, they will receive stale data. This is a direct result of a lack of coherence or consistency. To prevent this, we need strategies to ensure that when a write occurs to data, all cached copies of that data are either updated with a new value or invalidated, basically removed. Subsequent reads, particularly after a write, retrieve the correct up-to-date version of the data. This means you can't just cache and forget. You need a disciplined approach to managing the life cycle of your cached data. Okay, let's talk about some strategies for achieving cache coherence. While there is no single magic bullet for perfect coherence, several common strategies help to manage it. First, we have time to live or TTL. Basically how it works, each cached item is given an expiration time. After this time, the item is automatically removed or considered stale. The next request for that item will be a cache miss, forcing a fetch from the database to get fresh data. Number two, coherence aspect. It handles eventual consistency. Data might be stale for the duration of the time to live, but eventually it will be refreshed. It's simple to implement and manage. Number two, invalidation on write. Let's talk about how it works. So when data in the database is modified, the cache entry corresponding to that data is explicitly invalidated or updated. With write true, the write goes to both cache and DB simultaneously, ensuring consistency at the point of write. With the cache aside, after writing to the database, the application explicitly tells the cache to delete the stale item. The coherence aspect, this provides stronger consistency for writes. The cache is updated or cleared very quickly after the source changes. Number 3, publish and subscriber for distributed invalidation. Like, let's talk about how it works. In distributed system, when data is updated, a message is published to a messaging queue like Redis pops up, or maybe Kafka, indicating that a specific data item has changed. All cache nodes or services that hold a copy of that data subscribe to these messages, and upon receiving one, invalidate their local copy. The coherence aspect, ideal for distributed caches, allowing near real-time invalidation across many servers. It decouples the writer from the invalidator. Number 4, versioning. Let's talk about how it works. Instead of invalidating, you essentially treat each version of the data as a new entity. For example, by changing a URL to include a version number, for example, image.jpg version equals 2, something like that, you force the cache to fetch a new version while the old version might still exist. The coherence aspect effectively creates a new cache entries for a new version, relying on cache to understand the versioning in the key, primarily used for static or mostly static content. So yeah, cache coherence is indeed one of the most challenging aspects of building scalable, high-performance system. There is no single perfect solution that offers both absolute real-time consistency and extreme performance without trade-offs. The choice of strategy heavily depends on your application-specific requirements for data freshness, its tolerance for staleness, the volume of read versus writes, and complexity you are willing to manage. Mastering cache coherence means carefully balancing these factors to ensure your users always see the correct data efficiency. So yeah, that's it for this video, and see you in the future.